Hey guys, welcome back to my channel. Today we'll be looking at trigonometry. It's like an area in maths where a lot of students struggle with. So I'm going to start with the basics for you today. So with trig, we can use it basically to find missing angles and lengths of triangles. Trigonometry basically uses three functions. These are called Sine for short. We can write it as SIN, but we still pronounce it as sine. Cosine for short, we can write it as cos. Tangent for short, we can write it as tan. We will start working with right angle triangles. So looking at these right angle triangles, our first focus is to learn how to label the sides. So already you realize that I have hypotenuse because that one never changes, okay? And it's always basically that side of the triangle that's opposite to the right angle, okay? And another way that we can look at it, it's always the longest side. But sometimes just by looking at the triangle, you can't really identify the longest side. So the best way to remember it is basically to know that it is always opposite to the right angle. Okay, so the next thing I must say that the longest side, the one opposite to the right angle, is called the hypotenuse I mentioned before. So let's look at labeling the other sides. So what we call the other two sides will change depending on which angle we're working with. For example, if we're given this angle there, we label the other sides like this: opposite, adjacent. So you realize that the opposite side is always facing that angle that you are given, and the adjacent side, it helps to form the angle. Look carefully at what will happen now. If I change the location of the angle, the opposite and adjacent side also changes, okay? But what always remains the same is the hypotenuse. Alright, let's look at SOHCAHTOA, which is basically one method to remember the trig ratios, or one way to remember it. There are other ways, guys, but this is really easy to just remember SOHCAHTOA. Okay, let's look at the So, it really means sine theta. Theta represents your angle, guys, and that's equal to opposite over hypotenuse. Okay, and remember that the hypotenuse never changes, it always remains the same. The next one, Ka, that's cos theta. Again, theta represents your angle, that's equal to adjacent over hypotenuse. Okay, and the final one, Toa, tan theta, is equal to opposite over adjacent. And that's how we get SOHCAHTOA. And that's it, guys. That's all three of them together. You must remember these, and I'm recommending that the easiest way to do so is just to do your SOHCAHTOA and try to remember what each of those letters stand for. Okay, let's look at sine first, guys. For short, you can always write it as SIN. Here we have this right angle triangle. We're given an angle there, 30 degrees. We know the hypotenuse is 10 centimeter because it's that side that's facing the right angle, guys. And that 5 centimeter, it represents the opposite side, because remember, the opposite side always faces the angle that you're given. Okay, so that's your opposite, and that's your hypotenuse. It therefore means, of course, we're dealing with sine, guys. Okay, so I write my rule, which is sine theta is equal to opposite over hypotenuse. Okay, and then the next step now is for me to substitute the values that I know. Look at what will happen now, guys. If we try to enter sine 30 in your calculator, you'll get the same answer as 5 divided by 10. So sine 30 gives you 5 divided by 10, which is the same thing as a half. Okay, alright, let's look at an example which requires us now to find a missing side. Okay, so looking at this example, guys, we have 7 centimeter, we have that unknown side that we don't know, we call it O there, and we have an angle of 42 degrees. So our first step is to label our sides: opposite, hypotenuse. Again, we're dealing with sine once you're dealing with opposite and hypotenuse. Okay, Next step is to write our rule. Sine theta is equal to opposite over hypotenuse. And then now, the next thing that I need to do, guys, is basically to substitute everything I know. So sine 42, and why do I write 42? That 42, guys, it represents your angle. So the angle that you're given is 42 degrees, and it's opposite, basically to the opposite side there. That's fine. Equal to, I don't know my opposite side, so I write it as O over my hypotenuse, which I know is 7. And all I need to do now, guys, is basically to apply my algebra skills to find my unknown in this case, which is O, my opposite side. How do I do that? I multiply both sides of the equation by 7. When I do that, I should get 7 times sine 42 degrees equals to O. And then all I need to do is just get a calculator and just input that in. When I do that, I get an answer of 4.68 centimeter, correct to 2 decimal places. So what I'm saying is that my opposite side is approximately 4.68 centimeters. Okay, let's look at a second example now. So again, my first step is to label my sides. Opposite, that's my 10 centimeter there. HYP, hypotenuse, a label. So I'm still dealing with sine. My next step now, guys, is basically to write my rule. And again, it's good practice to keep writing it, that way you'll remember it. So sine theta is equal to opposite over hypotenuse. My next step now, guys, is to substitute all I know. And what I mean is basically to replace all I know. So sine of the angle, which is 17 degrees, so I write sine 17, is equal to my opposite side, which is 10, that's also what I know, over my hypotenuse, which I don't know. And again, use your algebra skills, guys, to rearrange to basically solve for your unknown, which is h in this case. So my first step now is to multiply both sides of the equation by h, because I need to get rid of that unknown out of my denominator. When I do that, I get h times sine 17 is equal to 10. Now I need to get rid of that sine 17, guys, because remember we need that h by itself. So the h is being multiplied by sine 17, so to get rid of it, it therefore means that I need to divide both sides of my equation now by sine 17 degrees. Let's do that, see what happens. So now I have h is equal to 10 divided by sine 17, and I put that in my calculator. I should get an answer of 34.2 centimeters, and that's correct to 1 decimal place. Now we're looking at cosine, and for short we can write it as cos. Okay, so looking at how we label the sides again, my hypotenuse, it always remains the same, guys, and my adjacent side now would have been that side that helps to form the angle. It's just beside it, guys. Okay, so we use cosine when we have the adjacent length and the hypotenuse, and this is what you need to remember. Cos theta is equal to adjacent over hypotenuse. Now let's look at an example. Again, we're trying to find that length A, okay, which is also our adjacent. So again, our first step is to label our sides just to confirm which trig ratio we're using. So that's my hypotenuse, that's my adjacent. So we can agree that we're really using cosine. So my next step now, guys, is basically to write my rule. Good practice, keep writing it. Cos theta is equal to adjacent over hypotenuse. Once I write my rule now, guys, the next step is for me to substitute all that I know. So let's do that now. We have cos 53 degrees. Again, that theta represents your angle. So that's cos 53 degrees equals to A, which is my adjacent. I don't know it, so I just write back A, over 9, which represents my hypotenuse. Next step now, guys, is really to solve for my unknown, which is A. I multiply both sides of the equation now by 9, and I should get 9 times cos 53 degrees equals to A. And my final step now is basically to input that in my calculator. When I do that, I get 5.42 centimeters correct to 2 decimal places. And that's my adjacent side that I was trying to find. Now let's look at another example. So again, first step, label your sides, adjacent, hypotenuse. Next step is to write my rule. Keep writing that rule. So cos theta equal to adjacent over hypotenuse. Next step now, guys, is basically to substitute the values I know. So I have cos 17 degrees equals to my adjacent over my hypotenuse. So my adjacent is 9 over h, which I don't know. Next step now is really to multiply both sides of your equation by h, because you need to get that h out of your denominator. When I do that, I get h times cos 17 degrees equal to 10. Next step, I need to get rid of that cos 17 degrees beside that h, because I need that h by itself. So therefore means I divide both sides of the equation by cos 17 degrees. When I do that, I get h is equal to 9 divided by cos 17 degrees. And when I put that in my calculator, I should get an answer of 9.41 centimeters correct to 2 decimal places. Now let's look at tan. Okay, again, first step is basically to label your sides. So that 10 centimeter represents my opposite side, that 6.4 represents my adjacent. And again, we know that we're using tan once we're dealing with opposite and adjacent. Next step, always write your rule, don't forget to write it. Tan theta equal opposite over adjacent. Let's look at an example now. So now we want to find the opposite side, but again, we first need to label our sides. So confirm yes, that's opposite because it's facing the angle that we're given. And that 11 centimeters, again, is my adjacent because it helps to form the angle. So we know that we're using tan because it involves the adjacent and opposite lengths. Next step, guys, is to write my rule. Keep writing that rule. Tan theta is equal to opposite over adjacent. And then I now substitute all that I know. So tan 53 degrees is equal to basically O, which represents my opposite, over my 11 centimeters. Next step is to multiply both sides of the equation by 11 centimeters. When I do that, I get 11 times tan 53 degrees equals to O, and that's what I'm trying to find. All I need to do now is to input that in my calculator. When I do that, I get an answer of 14.6 centimeters correct to 1 decimal place. Now let's look at our final example. Remember, first step is to label our sides. So that 21 centimeter represents our opposite side. A, that's our adjacent there. Okay, so we can use tan as the question involves adjacent and opposite lengths, and it's good practice to keep writing our formula. So our rule, tan theta is equal to opposite over adjacent. Our next step now, guys, is really to substitute all that we know. So we have tan 35 degrees. Again, that 35 degrees represents our angle, and that's equal now to our opposite, which is 21 centimeter over adjacent, which we don't know. Our next step now, guys, is really to multiply both sides of the equation by a, so that we can get rid of that a from the denominator. When we do that, we should get a times tan 35 degrees is equal to 21. Again, we need that a by itself, so it means that I need to get rid of that tan 35 degrees. How do I get rid of that? I need to do the opposite of multiply, which is basically to divide both sides of the equation by tan 35 degrees. When I do that, I get a is equal to 21 divided by tan 35 degrees. All I need to do now, guys, is just to put that in my calculator. When I do that, I get a is equal to 29.99 centimeters, correct to 2 decimal places. Usually in the exam, guys, they will tell you in terms of how many significant figures they need it to, or how many decimal places, so don't worry about that. Again, it depends on which examination body you're sitting an exam for. Okay, so don't worry too much about that. Alright, so it's really now for you to just get some questions online and practice some to make sure you're really confident knowing when to use what. Again, I would recommend just labeling your sides, and then that will help you to determine what you need to use. Again, guys, don't forget to just click that subscribe button if you haven't done so as yet. Like and share this video. Thanks for watching.